So with this video, I'm kicking off my Think Like a Developer series. In this series, I'm going to focus on how to think like a developer to solve problems in the real world. I want you to think of Python essentially as a toolkit. So you have different functions, libraries, or methods in this toolkit where you can solve open-ended problems with. And so in the real world, I think sometimes people struggle with, okay, if I have these requirements that I'm given, as developers often are, how do I decide which tools from my toolkit to use to meet the end goal of solving these requirements? So I'm going to walk through that sort of thought process in this series. So for today's project, we are given the requirement extracts key information from the large text files. And this is a common task in the real world in scenarios like analyzing customer feedback, summarizing documents, or preparing data for natural language processing. And so let's start with the thought process behind selecting our tools. So when we're given this requirement, the first thing I think of is, okay, so we're going to need to identify and count the most frequent words and phrases in the text. And so really to do that, this requires three main steps. The first is text cleaning, word tokenization, and frequency analysis. Whenever you're given a large open-ended data, the first thing you often need to do is text cleaning, because in the real world, oftentimes data is not ready to be used. You need to do something to the data so that it is first usable. And so to do these three steps, the text cleaning, word tokenization, and frequency analysis, I can think of three Python libraries that would be helpful in handling these tasks. The first library is the Regular Expressions Library, or RE. This is a module that is perfect for cleaning or normalizing any text, and it allows us to remove unlimited characters like punctuation. Regular expressions gives us a flexible way to search, replace, or split text based on patterns. And the next library I'm thinking of is the Natural Language Toolkit, or the NLTK library. And this is used for processing human language data, and it is a go-to library. We'll use it to tokenize the text, which essentially means breaking it down into individual words. And it also helps us filter out stock words that are common words that usually don't carry much meaning, like the word the or the word is. And another library we can use is the collections library, and more specifically, the counter function from that library. And this can be used to count and analyze the frequency of words and phrases. And so we turn to the collections module, and it allows us to tally how often each word or phrase appears, making it easier to identify the important ones. So now that we've thought through the general steps we need to take to meet these requirements and what Python tools we can use, we can start actually coding out our solution. And so we're going to start by reading the contents of the text file. And so notice that we're converting all text to lowercase with the .lower method. And this ensures consistency so that words like Python with a capital P or Python with a lowercase p are treated the same. And anytime you're working with string data, you need to keep that in mind. Is your data case sensitive? And in this case, it's not. So we're going to turn it all into lowercase. And so now we can start with cleaning the text with the Regular Expressions library. And so this is where we're going to use the sub function from the library and pass in our text file to remove any punctuation from the text. And so the part of that is the /w/s, that is targeting anything that isn't a word character or white space. And so it's effectively stripping out punctuation marks like commas, periods, or hyphens, because once again, in this scenario, that's not important, so we just want to eliminate that noise. And now we want to count our word frequencies. So with the filtered list of words, we create a counter object that counts the frequency of each word. And by calling the most common function and passing in 10, we extract the 10 most frequent words, which likely represent key topics in the text. And so the counter function from the collections library is super awesome whenever you're wanting to count frequencies of any sort of iterable. And so now we also want to identify common phrases. So beyond individual words, it's often useful to identify common phrases. We generate bigrams, which are pairs of consecutive words, using the bigrams function from the NLTK library. We pass in our filtered words. These bigrams are also counted with the counter function, allowing us to find the top 5 most frequent phrases. Finally, the results are printed out showing both the most common orders and the most common bigrams. This output gives you a summary of the key information within MISText file. As you can see, we were given a requirement, and we didn't have some magic function or formula that gave us the specific thing we needed. But we did string together different Python libraries and functions to come up with a solution. So I'd love to know in the comments if there's any way you would have solved this differently, and let me know if you do have any questions about the code we covered today.